All right, welcome back, everyone. For the people that are watching on video, this is Math 54. Well, I hate giving them numbers because the numbering is going to change. This is pre-calculus B or trigonometry. We're doing 8.2, and this is covering law of cosines today. I'm going to show you how to derive the law of cosines. So let's set up a coordinate system where we're going to make a triangle where one of the points is at the origin. We'll put another point out here and another point over here. This will be angle A, that'll be side A. Angle B, side B. And angle C, side C. All right, to derive the law of cosines. How to derive the law of cosines. What we're going to do is I'm going to make a right triangle using point A, dropping a line down. So that we have this. And we don't know what height that is, and we don't know this distance to the left, so we're going to use y and x. So if we want to figure out what stuff is. If I want sine, let's see, I'm going to use this angle here. Let's call this D. D is 180 minus B. And so if I did sine of D is sine of 180 minus B. Which is sine 180 cosine B minus cosine 180 sine B. And we get 0 times cosine B minus -1 times sine B. It turns out sine of D is the same thing as sine of B. That's convenient. Because now I can work with this triangle for some information. Even though this is angle B, I can still use this angle because it's got the same sign. Because it's also related to the y value. So we're gonna work off the smaller triangle to get some information. Sine B off the sine D or sine B off the smaller triangle is opposite over hypotenuse, y over c. So that y equals c times sine of B. We'll do the same thing with cosine. Cosine B. Is x over c. So x equals c times cosine B. Everyone follow that? What does that make the coordinates for point A? Well, the x value is c cosine B, but it's negative because we're going to the left. So negative c times cosine B. And the y value is c sine B. What about point C? What is its coordinate? Well, it's gone out a distance from the origin x or A, so x equals A there. And it's on the x-axis, which means y equals 0. So we're looking at these 2 points here. Does that track?
How does x equal a again?
Because this is angle A, so this is side A. This is at the origin, which means this is going out a distance A from the origin. Which means from along horizontally, that's an x distance.
Oh, I see.
And since we started at the origin, it's only A.
I was confusing it for the side x.
Right. So if I wanna find side B. I can use the distance formula on side B. If you've forgotten it. D is the square root of x2 minus x1 squared. Plus y2 minus y1 squared. You know what, I'm gonna make this positive here because I think the negative is gonna fall out all on its own. The cosine is gonna be negative, and so. The negative is gonna fall out from cosine. So I'm gonna leave that as a positive. So if I call this 0.1 and this 0.2. D, which is side B. My distance is side B. It is the square root of. We've got A minus C cosine B. Squared. Plus 0 minus C sine B squared. I'm gonna square this. And I can actually clean this up right away and make this c squared sine squared b. Cause the 0 isn't changing the value there. We're just squaring negative c sine b and we get positive c squared sine squared. Alright, so multiply this out. You're gonna get a squared, cause remember, this is a minus c cosine b times itself. So we can't just square each term. We have to FOIL. And we're gonna get a squared minus two ac cosine b. Plus c squared cosine squared b. That's expanding the parentheses. And I still have plus c squared sine squared b. We're almost done. Notice. I can. Factor out a c squared from these two. And what does cosine squared b plus sine squared b equal? 1. So what I get if I put the, that goes to 1, it kind of goes away. I get b squared equals a squared plus c squared minus 2ac times cosine b. This is the law of cosines. It relates the sides of a triangle to the cosine of one of the angles. Law of sines related sides of a triangle to the sines of angles. This relates law of sides to the cosine of an angle. Now I arbitrarily named A, B, and C. I could easily pick different letters for each of the things. Notice. What has to hold true is this needs to match that. At least be the side opposite each other. And then whatever these are these. So these pair up and are the same as this. And these are angle and side. So there are 3 forms of the law of cosines. I'll start with the one that says a squared. A squared equals b squared plus c squared minus 2bc cosine of a. B squared equals a squared plus c squared minus 2ac cosine of b. And the final form is c squared equals a squared plus b squared minus 2ab cosine of c. These are the 3 forms of the law of cosine. And that's for any triangle. Not just right triangles. Does it work on a right triangle? We know this by Pythagorean formula is a squared plus b squared equals c squared. That would be angle A, that would be angle B, and C is right there. I'm gonna use this c squared equals, we're gonna test this. We're gonna use this last version. C squared equals a squared plus b squared minus two ab cosine c. And we don't know the lengths of any of the sides, but we need to know the angle of C. C is the right angle, or 90 degrees. And what is the cosine of 90? 0. So this is 0, which makes this whole thing 0. And we still get c squared equals a squared plus b squared. Our good old Pythagorean formula. Wake up, Davis. His eyes drip shut as soon as I stop talking. I need to perpetually speak. What's up, Davis? You raise your hand.
For the area of the triangle, it's always.
Yeah, it's just figuring out what the height is sometimes. We are actually gonna do another formula today for the area of a triangle. Called Heron's formula. Which is some fucking crazy shit. Let's do some problems with this then. Maybe I will leave that where we can see the equations. Alright, so we got two boats, they leave harbor. And travel in a straight line. Making an angle. Let's go with 82 degrees, 20 minutes. Between the directions of travel. The slower boat. Has gone. 62.5 kilometers. And the same time. The faster boat. Went. 79.4 kilometers. How far apart are the boats now? Like picture. Yeah, does it sound like it look like 82 degrees? Fuck it, I'm still calling it 82.2. Not 0.2, but 82 degrees, 20 minutes. Nah, I can't do it. Let's make it look a little more, like that would be 90, so maybe that's 82. We'll do that. And we'll make the slower one be the vertical one, so it's got a shorter line. This is 62.5 kilometers. And that makes this distance 79.4 kilometers. So this boat's over here. And this boat's over here. And we wanna know how far apart they are. So this is the unknown quantity. Call that C. Which would make this angle C. If it helps, we can label these angle A with side A. And angle B with side B. So I've used this one for side C. And angle C, we want the one where the formula with angle C in it. So we're gonna use C squared equals A squared plus B squared. Minus 2AB cosine C. C squared equals 62.5 kilometers squared. Plus 79.4 kilometers squared. Minus 2 times 62.5 kilometers. Times 79.4 kilometers. Times cosine of 82 degrees, 20 minutes. Eek. I don't like having the minutes in there. So. When I put it in, I'm gonna just put in, make sure I put in 82 plus 20 over 60. Cause that is not 0.2. So 82 degrees plus 20 over 60 is how I'll enter in the calculator. But this is just all calculator shit. I'll do little subcomponents, so we can see what it looks like along the way. The 62.5 squared is 3906.25 kilometers squared. Then I've got plus B squared. 6304.36 kilometers squared. And then what is this value right here? 2 times 62.5 times 79.4 times cosine parentheses 82 plus 1 divided by 3. And on this one, I'm getting 1324.09. I have a 2 in there. 2 times, let's see. 2 times 62.5 times 79.4. Yeah, that's looking right. Alright, we do that all together. $8,886.5. Two. Kilometers squared. And if we take the square root of the answer. C equals. I'm getting 94.3 if I round. And it's not squared, it's just kilometers. Someone else verify that. Owen's doing it, did you get the same thing on?
I must have put something in.
I might have put something in wrong too.
I doubt it's in the 8 digits.
Oh wow. Let's try this again.
I got 8,902 kilometers squared.
I'm still getting that, I will. Check the individual components. So 82 divided per plus. Divided by 3, and now the cosine of that angle. Multiply that by 2 times 65. 74. I'm still getting all those. Did anyone else get what I got? Okay. Okay, a couple people got it, so. If you might have fat fingered it or put the keys in the numbers in the wrong order at one point or shifted the decimal point. You shift the decimal point, you should be off by a lot. But that's how that works. You might find it easier to do. 82 plus 1/3 first. And you get 82.33333. Then do cosine of answer. And then multiply that by the rest. Or if you're practice with calculator, you just on. Alright, ready for another one? Wait, it's time for a break. I gotta give a break. Alright, let's see our next problem. We're gonna solve triangle ABC. Like solve means find all sides. And angles. And we are gonna have B equals 73.5 degrees. Side A is 28.2 feet. And side C is 46.7 feet. Pro tip, try to make the angle that you're working with look approximately like the right angle. And then. At least, it's kind of hard to make these two the exact measurements. But at least make the side that looks longer be the longer side. Okay? So like. If I were going off of this angle, like that would be like 73.5 degrees. So I'll call this B. I'm gonna, since the way I drew this. I'm gonna make the longer side on bottom, we'll make this the 46.7. And that'll be the 28.2. And these are in feet. And yeah, the 46.7, it kind of looks like more than double the other one. But either way, I got the long side looking longer than the short side. If I label these, this was A. So that'll make this angle A. And this was C, so this is angle C. Can I use law of sines here? We're gonna have a problem, right? We're not missing one thing, we're missing two things if we do the setup. Like I don't have B and I don't have these. I don't have a complete set of information for an angle on the side, that's where sine shines. So not helpful. Yet. So let's just jump to our law of cosines, we have angle B. So that will be what I have at the end, I'll have a cosine B. Which means I'm working with B squared on the other side. The two remaining sides are A squared plus C squared. And then I do minus 2AC, the sides that are on the same side. And we'll plug in what we have. I've got B squared equals 28.2 squared. We'll just note that B is gonna be in feet later on, and now I don't have to need to write it down as much. And then we have C squared is 46.7 squared. Minus 2 times 28.2 times 46.7 times cosine of 73.5 degrees. Alright, I'm gonna try to do this all in one pop in my calculator, that's definitely faster. I recommend if you do it in your calculator all at once, do it twice. That way you make sure you get the same answer both times. Cause if you don't, it means you fucked up one of them. So my initial run, I'm getting B squared is 2,228.07. B squared, let me try it again, make sure I get the same answer. And I did not get the same fucking answer, son of a bitch. This time I got this. So which one of these is right? Oh, I didn't have the 0.2 on the second one, this one's. You got the first one? I think I missed the 0.2 when I was doing the second round. Alright, so. What is the square root of that? B equals 47.2 B. Alright, so. We still need to find angle A and angle C. So how do we choose which one to do and how do we go? So at this point, law of sines works well. We'll be faster. But. Remember, law of sines can lead us to a scenario where we get like two triangles, and we know we don't have two triangles. So the way you avoid getting the option of two triangles is choose to go for the angle with the smaller opposite side. That is going to forces that angle to be less than 90 degrees. And that means there's no second option. So in this case, the shorter one is side A. Between A and C, so I'm gonna use A to go with B. I am looking for sine A, so I'll put sine A on top. Over A is 28.2 feet. Equals sine of 73.5. Over 47.2 feet. If I do that, I get sine of A. Equals. Clear the fractions. And sine A is 0.572854163. And I will do sine inverse. And I'm getting A equals 34.9 degrees. Anyone else get that? Okay, good. So we wanted to find B. We wanted to find A. The last one we need is angle C. What's the easiest way to find C? Yeah, don't use either law at this point. Use what you know about triangles, they add up to 180. So C will be 180 minus 73.5 minus 34.9. And I'm getting 71.6 degrees. Alright, so. When we're solving a triangle. We're gonna do another case that's a little bit harder in a second, yeah,
Some. That's using the law. It's kind of like 73.5.
you wanna do it as a verification.
Yeah, I guess you 73.5 and 30.9.
Yeah, this one, Like all of the ones that are boxed are approximations because I rounded. So maybe it's probably better to put. The approximate symbols in rather than saying equal. Cause they are not equal. This is. No. If I did this up here. That's the exact version of B. But like it's not useful in that form. Even there, I rounded. So as soon as I rounded, I introduced error. Error is bad in physics and engineering. But it's gonna exist, we can only get so accurate with calculations and measuring tools. You can only get, measure so well. But you try to minimize error. So in this case, we had two sides and an angle. And if you kind of notice the setup, it was like a side angle side. I had side, the angle between them, and a side. So when we do this, step one, find the missing side. With law of cosines. Then you need to find one of the two angles. Find the smaller angle. By focusing on the shorter of the two sides. And you can do this with law of sines or law of cosines if you want. But I think most people are gonna default to law of sines because it's easier. But this makes sure, that makes it so you avoid the second triangle. And then obviously, once you have that, you got one angle left, just find the angle. What happens when we have three sides? Side, side, side. Law of sines is still not our friend because we don't have any angles, so we can't do anything with it. And so law of sines isn't where we're gonna start. What you wanna do is step one, focus on finding the largest angle. By using the longest side. This will forces both other angles to be less than 90 degrees. If you choose like the middle length side or the shorter side, it doesn't force shit. But if you choose the larger side, then the largest angle opposite is it, and there's no way you can't generate an angle that's above 90 degrees if you've already used the largest angle. So that's what we're gonna do in the following example. Let's solve. Oh. Then find the rest, however you wish. Law of sines is a good choice for the second angle. I think it's something fun to do for my computer science students, they did vectors recently, and I gotta make some fun project that's personalized. If I don't personalize it, I use generic problems. Half the class is gonna try to submit AI shit, and I have to tell them, you cheated. And then 90% of them are gonna say, no, I didn't. And I'm gonna say, well, tell me what your code means, and I'm gonna go, I don't know. And I'm gonna go, how did you write your code if you don't know how it works? I don't know. Are you still sure you didn't cheat? Yep, I didn't cheat. You're a fucking liar. Now I'm dealing with someone I'm mad at and fucking lied to me. It's just easier to avoid by personalizing it. I have a lot less of that happening. Don't use AI at college, folks. Use AI in your jobs when you're expected to know it and you need to work faster. Cause AI isn't always right, and you'll at least be able to recognize when it's wrong. Right? AI fucks up all the time. I can't tell you how many times I've put in a calculus problem and it spits out the fucking wrong answer. And I know it's the wrong answer because not because it doesn't match mine, but when I go through their work, they'll do some shit like 2 + 3 is 8. I'm like, the fuck? That's basic arithmetic. How are you fucking up stuff that a fucking third grader knows how to do? It's just. Bad input, bad output. Alright. Example. Everyone should have had time to write that down. Let's go with solve ABC. A is 25.4 centimeters. B is 42.8 centimeters. C is 59.3 centimeters. Alright, so we got a triangle. One side is short. I'm gonna say the bottom looks like the longest one to me, the way I drew it. And by choosing those the way I did, that forces this one to be A. B is opposite the 42.8 and C is opposite the 59.3. And I'm gonna write the word centimeters in the middle, that way I remember that. Well, no, we're just finding angles, so it's not important. The fucking units aren't gonna matter, we're gonna be working in degrees or radians. Degrees makes more sense, it's a little easier to figure out what's going on. To make sure like that tracks, that's about the right angle kind of thing. So. Focus on the longest side. The longest side here is C. So we're gonna find cosine C. Because C is the longest side. Which means we're going with the option that has C squared equals A squared plus B squared minus 2AB cosine C. If you want to do it all as one calculation, I can subtract over A squared and B squared, subtract them from both sides. And then if I divide both sides by negative 2AB, I can isolate cosine C. Cosine C And I don't wanna have a negative on the bottom, so I'm just gonna change all the signs on top. And make this a negative, this a positive, this a positive. I'm gonna have a squared plus b squared minus c squared over two ab. That'll help me find cosine C and then I do cosine inverse. This should look like the formula you had on your phone. That's what was going on. In fact, that's why I did it this way rather than filling them in first. If you didn't do the negative sign, you could have negative a squared minus b squared. Plus c squared over negative two ab. But like having the negative on bottom, you're more likely to suck up some stuff along the middle. So I strongly recommend using the top. So that's what we're gonna do. Cosine C is gonna equal a squared, which was 25.4 squared. Plus b squared, which is 42.8 squared. Minus 59.3 squared. All over. 2 times 25.4 times 42.8. Now, if you're gonna do this all on a calculator once, maybe do brackets around the top. Or parentheses. And parentheses divided by start parentheses. 2 times 25.4. So I'm getting cosine C is negative 0.478093.494. And I'm gonna do that again real quick, just to make sure I'm right. And that's what I'm getting. So I'm gonna get angle C is cosine inverse of that. And it's telling me 118.56 degrees. Just say 118.6 degrees. Notice this angle's already over 90 degrees. I don't need to worry about having a second angle no matter what I do on any of the other ones. So now that we have that. Maybe I'll make a little. A, B, C. A, B, C. And I just approximated C to 118.6. So now it doesn't matter which one we do. Who wants to do A, A or B, someone pick. A, there we go. So we're gonna find A by doing sine A over A. Equals sine of C. Over C, which was 59.3. So sine A. Is A, which is 25.4 over 59.3. Times sine of 118.6. multiply rather than divide by 59.3. Giving 0.376. I do sine inverse. And then if I wanna find B. E equals 180 minus the two angles I have. .3 degrees. Oh. So, we've got one more equation, it's Heron's formula for area. Does anyone need the rest of this old question? Okay. So the other one we did, the area like an hour and a half ago, we had an angle. This is for a triangle where three sides are 90. And you don't wanna waste time figuring out one of the angles, just use one of the formulas. So. Heron's formula for area says area is square root. Of. S. Times S minus A. Times S minus B. Times S minus C. Maybe I should have used lowercase a, lowercase b, lowercase c. Cause it's definitely the sides. And S. Is 1/2 the perimeter. S is short for semi-perimeter. Not approximately, it is the semi-perimeter. Or half the perimeter. Now. You derive it using the law of cosines, and it's a long process. I don't know, if it's helpful. This is easy to use though, this is very easy to use. So let's go back to our last triangle and find the area. Our last triangle, we had A equal 25.4 centimeters. B equal 42.8 centimeters. And C equal 59.3 centimeters. S shows up everywhere, so find S first. S equals 1/2 25.4 centimeters plus 42.8 centimeters. Plus 59.3 centimeters. I'm getting S is 63.75. So area is square root of 63.75 times 63.75 minus A, which is 25.4 times 63.75 minus B. And then 63.75 minus C. Now, if you've calculated this first, your calculator likely has this stored as answer. So you can speed this up by doing answer times parentheses answer minus whatever A is, times parentheses answer minus whatever B is, times parentheses answer minus whatever C is. Hit equal, then take square root. And my A that I'm getting before the square root. $227,923.7573. Take the square root of that. And I'm getting 477.4136 centimeters squared. I had 3 significant digits. I'm gonna round this to 3 digits. 477 square centimeters. Anyone else get that? It's square? Area is definitely square. Cause this is a centimeter and these are all centimeters. So I have the square root. Of centimeter to the fourth. Which results in centimeters squared. Did anyone else get 477?
Yeah.
Okay. This can be useful if you're trying to find area like in real life, like. You've got a fucked up triangular piece of land and you're like, how much square footage do I have for props? And you know, there's like a river fucking up your shit, so you can't make it like a rectangle. You can at least measure the size and figure out how much area you're getting. Stuff like that. Any questions? Alright, that's all I got for you today. What are we doing next?
I think we're doing vectors.
Or you. I don't know where the fuck that came from. Okay.
Programming fundamentals classes, font 006.
What's its name? Does it have another name?
This is just programming fundamentals.
I wanna say it's mathy. There's some logic courses in it. I have not taken it. I think Dylan teaches it, John.
Forgot the name, but it's fully online.
Oh. Oh, let me look. Let me stop recording.
Oh, yeah.